Okay guys, let's begin. Now, what we have here is two brothers own Peter begin work on in 2005 on starting salaries of 20 grand and 17 grand per annum. Own salary is going up by €500 a year. So he's going to be on the following numbers for the next couple of years. We're just filling out adding on 500 each time. That makes sense? Then we have Peter's salary, which is increasing by more. So he's going to be 18,100 and... Oh sorry, I put in one too many numbers there. You got a bit too much of a raise. 18,250, 1950, 2750, 22,000. So you can see this is the point at which both of them actually start earning the same salary as each other. And then after that he overtakes them to 23,250. And what year will both brothers earn the exact same amount? Year 5. Explain what an arithmetic sequence is. An arithmetic sequence is a sequence where each number goes up by the same amount each time.
I said reoccurring sequence.
No, not necessarily like that. A recurring sequence could be something like this.
Yeah, like it's going up in the number.
Yeah, but then it goes back again. So it has to go up by the same amount each time. So the difference between terms is exactly the same. Do you agree with Owen? Explain your answer. Yes, I agree with Owen because every single year it goes up €500, and this is exactly what a arithmetic sequence is. Same difference every year, or same difference between years. You get that? Okay. Is there? Must be missing part D, am I? Down here. Find in terms of n a formula that gives own salary in the nth year of the partner. It's an arithmetic sequence, which is this here. What's the A value?
The A value is 20.
20,000, yeah? The D value? So we just plug in the Tn formula, and we can see that this is quite an easy question. Multiply it out. 500n minus 500. And after that, 19,500 n plus 500n. Everybody cool with that? Tn?
What you have 19,500n.
Oh, sorry, it's not 19,500n. It's 19,500. Okay, that's been easy money so far, hasn't it? Especially in comparison to the other questions we've done. You really can get lucky and unlucky depending on the year. Okay? Use your formula or otherwise calculate own salary in 2015. Now here's the awkward one, alright? That's 2005, isn't it? 2006, 2007, 2008, 2009, that's 2010. 7, 8, 9, 10, 11. 7 is 2011, 8 is 2012, 9 is 2013, 10 is 2014. That means 11, or T11, is 2015. So therefore, you have to go all the way down here, and you find out what T11 is. What you get for that? 19,500 plus 500 times 11? 25,000. Everybody alright with that? 25G?
25G.
Anybody get it?
You don't have E or
Huh?
you don't have E or F or G or H.
Yeah, I'm going to do that now. I didn't photocopy it.
No,
It's not there, isn't it?
no, it's here.
Okay. Alright. Find in terms of n a formula that gives the total amount earned by Peter from the first to the nth year department. Basically, it wants me to look at Peter's 17,000, and it's the A value, and D is 1,250. It wants me to find out his total over the first 11 years, or the first 11 terms. Is that T11 or S11? It's looking for T11 or S11? S11. T11 is how much he earned in the 11th year only. S11 is how much he earned for all the years up to and including the 11th year. Does that make sense? So what we're going to do is we need the Sn formula. Sn is n over 2 into 2a plus n minus 1 times d. Okay. So we'll just find Sn first, okay? So A is 17,000. So what's 2 times A? 2 times A? 34,000. Would you agree with that?
I would.
2 times 17,000. D is 1,250. Multiply it out. 1,250 n minus 1,250.
Wait,
Yes.
this is for Owen's salary.
That was Owen's salary,
Yeah.
not Peter's.
Using the formula, otherwise find Owen's salary.
Oh, sorry, my fault. I'm just gonna. Oh dear. I'm not gonna undo that work because I'm gonna need it for down here anyway. So I'll just bring it down here. Sorry about that, guys. Why is there an extra n over 2? I do not know. Okay, sorry, my fault. And A and D here. Sorry about that, guys. I did Owen's salary instead of Peter's instead of Owen's. So what's Peter's again? 20,000.
Peter's is 17. No, Owen's is 20,000.
And a difference of.
Okay.
Thanks for that. Okay. So we're going to get this time is and we know the n value as well. We know n is 11, don't we? Because it's the 11th year. So we actually have all the numbers we need. So we just say 11 over 2. 2 times A? 40,000. What's n minus 1? Is 10. Because it's 11 minus 1 is 10. 10 times that? 10 times 1,250? 1,500. And what's 11 over 2 multiplied by 52,500? Anybody? Or 5.5 multiplied by 52,200? Anybody?
20. Whoa.
Big number though, right?
288,000.
Yeah.
750.
750. Okay. Everybody alright with that? Now, the next one. Find it in terms of n, a formula gives the total amount earned by Peter from the first year to the nth year. We don't know the n value this time. We know that D is 1,250 and we know that A is 17,000. We're using the same formula as we did above. Using this formula here, and that turns into that there once you put your numbers in. Next we're going to fix it up. N over 2. 34,000 take away 1,250.
82,750.
Okay. Now, that's my Tn right there. Everybody happy with that being Tn?
Yeah.
I could multiply it out and divide by 2 if you want, but I think you'd be far enough along there. Then goes, using your formula otherwise, find the total amount earned by Peter. How many terms is that from 2005 to 2015? 11. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 11. So it wants me to find out what S11 is. How do you find S11? S11, anybody? Oh, see, that's SN there, not TN. So then 11 over 2 into 3,200, plus 1250 times 11. And what do we get there when you multiply it all out? Thousands? 750.
It's always on paper one.
Yeah. Put it on. Ready? Moving on. Okay, one reason why the graph below is not an accurate way to represent Peter's salary over this many years.
Because the salary isn't slowly going up.
What?
The salary isn't going up slowly, it's spiking up every year. So it's not like.
Oh yeah. It's wrong because like if you say halfway between 2005 and 2006, if you say his salary is above 16,000, you'd be wrong. Because it's 16,000 all the way through 2016, and then it's 17,250 only at the start of. It's not, the word is, it's not continuous data. It's not continuous is the technical term. It starts and the new wage only starts at the start of each year. So that's good, well done, Declan, excellent point. Everybody alright with that?
Yeah.
Cool. This one. We have a bunch of tiles. The first three patterns, sequence continues the same way. In each pattern, the tiles in the square, there's two diagonals. There are no tiles in the white areas of the patterns. Can somebody be nice enough as to count, does somebody already have these tiles counted up?
Yeah.
How many in the first one, Oscar?
21.
21. The next one?
33.
The one after that?
45.
45. It's a gap of,
12.
which makes it a linear sequence. Okay, and there's your next three numbers. Find in terms of n the formula that gives the number of tiles in the nth pattern. What formula are you going to use, Declan?
I use the TN equals plus n minus 1
Times d, which is 21 plus, so 12n minus 12. 12n plus 9. Just check it, always check. If you put in n equals 2, what's your answer? 12 times 2? 24 plus 9, 33. Always do that check, do you understand? If you want an A or a B, just stop, check out what you got, make sure it works, then move on. Don't just go straight on. Okay? Use your formula, otherwise find the number of tiles in the 10th pattern. T10 or S10? T10. Number of tiles in the 10th pattern only. 12 times 10 plus 9, 129. Everybody cool with that? Okay. Sheila has 399 tiles. What is the biggest pattern in the sequence that she can make?
32.
Tell me something. Is it T399 or is it TN equals 399? TN equals 399. You got that?
Yeah.
Now, there's another little cheeky thing you can do with this. See this formula here, 12n plus 9. I can put that into my table function. I can say, call it 12x plus 9. I can go from 1 to, I don't know, 1 to 15 maybe. Let's see if that,
35.
1 to 11, let's see what happens, right? See the way it's going up? Yeah? The 10th pattern has 129 tiles, the 11th pattern has 141. Alright, look, I'm not getting through that fast enough. Let's go up in 5s, up to 40. Okay, and look at this. Oh, somewhere in between 30 and 35 is 399. We're fine again. It's a very effective way at narrowing down exactly what you're looking for. 32, pattern 32 has 393 tiles, while pattern 33 has 405 tiles. I have enough to make 32, but not to make 33. Now, how do you solve that normally? It's not T399, it's Tn equals 399. 12n plus 9 equals 399. 12n equals 390. 390 divided by 12. 32.5 needs to be rounded down to 32. Isn't it really good though to have the calculator completely reassure you of what actually happened with all those patterns? That's what I'm saying, you have such a certainty when you use the calculator as well. Okay? Find the formula of the total amount of tiles in the first n patterns. Tn or Sn? Sn. A is 21, D is 12. 2a plus n minus 1 times d. Okay, Sn equals n over 2. 2 times 21? 42. D is 12. Multiply out. 12n minus 12. Yeah? Then after that, 42 minus 12. 30, isn't it? Now, here's the cheap way of doing this. Multiply everything by n and then divide by 2. 30n divided by 2? 30n divided by 2, anybody? 15n. 12n squared divided by 2? 6n squared. So it's going to be 15n plus. Okay, perfect. Sheila starts at the beginning of the sequence and makes as many of the patterns as she can. She does not break up old patterns to take the tiles to make new patterns. For example, after making the first 2 patterns, she's used up 54 tiles. How many patterns can she make for 399? What do you do here? Is this S399? Is it T399? Is it Tn equals 399? Or is it Sn equals 399? Sn equals 399. But let's explain what each one is. T399 is how many tiles you need to make the 399th pattern. Does that make sense?
Yeah.
Which will be a load of tiles. You eliminate that out because that's simply not what it is. Tn equals 399. What pattern has 399 tiles, if it exists? Or which pattern is going to be the closest to 399 tiles? Get rid of that. What's S399? 399 patterns. How many tiles in all 399 patterns? Whopper number, right? And finally the last one. How many patterns, when added together, will have a total of 399? Now, what you can do next is just do the Sn formula. We have it up here already, don't we? 6n squared plus 15n equals 399. Safe to say we'd be doing a minus b formula, right? We're going to do a minus.
Divided by 3 and make it smaller.
You could do. Still say I'll be doing a minus b formula anyway.
Yeah.
So a equals 2, b equals 5, c equals 1, 3, 3, minus b equals minus 5. Minus 5 plus or minus the square root of b squared minus 4ac all over 2a all over 4 square root of. Does this have to be a positive answer or a negative answer? Should be positive, shouldn't it? 33, I'll take that. It's not even a square root sign, it's actually just 33. So we're going to take it as 30 minus 5 plus 33. 28 divided by 4. 7.
Sir, I just counted.
You counted? That's okay, you'll get high partial credit or full marks. But